Improvement Opportunities. This is the first module of the program and session number 4. This program is consisted of 2 modules and 1 special topic, as you can see from the table. The first module has 4 subsessions focusing on discussing process. This is the 4th session of the first module. In this session, we will discuss basic variables that can increase the output performance. Those basic variables and options that we can change or improve in order to improve the output performance, and we will have a chance to compare which one is the best one that we can focus on. Then we will think about future operations. Even today, there are different kinds of advanced technologies that have been adopted by modern manufacturing or operations in general. Under the situation of rapid technology development, we will think about the opportunities that we can apply AI technology. There are many output out of the process that we can think about. Amount of products, quality of the products, or one-time delivery and low cost. Here, we will put the capacity, which is the matter of how much to produce, as a focal output for now and think about related variables. As we discussed, the amount of outputs, which is capacity, equals to available time divided by cycle time, is a very simple and common sense type of equation. For example, if you have 8 hours per day and the speed of producing one item is 1 minute, in other words, 1 minute of cycle time, you can easily calculate the available maximum output that you can produce through this process. Since each hour has 60 minutes, 8 hours is equal to 480 minutes. Therefore, 480 minutes of available time per day divided by 1 minute of cycle time is 480 units. This is the kind of basic question that we learned in middle school or at least high school. If I drive my car at a speed of 60 miles per hour, how long would it take to travel to a destination that is 480 miles away? Isn't it? Now, let's think about the idea of increasing capacity. If you need to and want to increase the capacity, what are the options that you can take? As you can see, either you should increase the available time or decrease the cycle time. Let's think about the option of increasing the available time. From the previous example, we had 8 available hours per day. So, how do we increase the available hour? We all have 24 hours per day. In the real world, what we can do is add the second shift, extended work hours, and so on, or reduce the cycle time. However, as we discussed, the cycle time is determined by task time divided by available resources, as you can see in the next slide. The speed of producing a unit of product is determined by how quickly the task is completed and also by the number of workers at the workstation. For example, if it takes 1 minute to take care of a specific task, which is the task time, and there is only 1 worker at the workstation, the speed of producing the output at the end of this workstation will be 1 minute, meaning that you will get 1 output every minute. If there are 2 available resources, like 2 workers under the same condition, every 1 minute you will get 2 outputs. The meaning of this is that you will be able to produce 2 units of output every 1 minute. Therefore, mathematically, the cycle time is 0.5 per 1 unit because it is 1 minute for 2 units. Now, let's think about the way that we can reduce the cycle time. There are 2 options, like either you reduce the task time or increase the available resources. The meaning of reducing the task time is working faster to complete the task in some way. As a human being, there must be a limit to reducing task time unless you use a creative method. As for the available resources, it is actually such a basic idea that everyone can think about. Which one would you choose? So, if we collect all of this information, the integrated equation looks like the one at the lower part of this slide. The capacity is equal to available time divided by cycle time, and the cycle time is equal to task time divided by available resources. Finally, the integrated equation will be like the one shown in the slide. So, in order to increase the capacity, there are 3 options. First, increase available time. Second, increase available resources. And third, decrease the take time. Which one would you choose? There might be pros and cons for each option. Let's think about the first option, increasing the available time. There will be different ways to increase the available time. For example, overtime. Let people work longer than normal time. Then you need to pay more because the overtime compensation rate is generally more than 1.5 times. Obviously, there will be additional costs such as extra power, meals, insurance, administration, and so on. In addition, if you use machines and tools for overtime, the value of those assets can be depreciated faster, resulting in more cost. If the demand is large enough, you can add another shift. For example, you run the first shift from 7 a.m. to 3 p.m. and the second shift starts from 3 p.m. to 11 p.m. so that you can produce double the amount of output. However, if the demand from the customer does not increase by 2 times, the increased capacity can create some extra inventory or less than 100% capacity utilization. This is because you may want to work more slowly if you want to increase the capacity, but by less than 2 times the original capacity, while still making it bigger than the current capacity. So, it is not a simple decision, and a lot of unexpected costs can occur. Now let's think about the second option, which is increasing the available resources. If it is manpower, in some industries or countries, it could be very difficult to lay off employees, although you could easily increase manpower. If you increase manpower, there are related costs that the company needs to invest in, such as insurance, welfare, space, retirement plans, and even more communication and coordination efforts. If it is a machine, obviously you need a significant initial investment and space, and you also need to take care of maintenance and depreciation of those assets. In addition, capacity utilization could be an issue if demand does not increase at the same rate as the capacity increase from adding one more unit of the machine. Sometimes the material flow needs to be redesigned due to the additional machine, and so on. In general, owners may not like this idea unless the benefits of adding available resources are much bigger than the cost of adding them. Finally, the third option is reducing the task time. Basically, this option is to think about how you currently work and improve it in a way that reduces the task time. As workers become more familiar with the task, they can complete it faster. By sharing that knowledge and those insights with other workers, performance can also improve as a group. Sometimes, experienced workers can bring creative ideas for reducing the task time and share them with others. At the surface level, there is no need for significant investment or cost. However, it is difficult to motivate workers to think about creative solutions or even improvement opportunities unless there are tangible incentives. Some organizations use honor or respect as intangible incentives to motivate workers, or suggestion systems combined with honor systems. For example, in order to reduce the time to find the right size of bolts and nuts, they created containers that categorized different sizes of bolts and nuts so that they can reduce the time needed to find the right size to less than a second. In order to reduce the time needed to find the right tools, they organize the tools in the same way and location systematically, finally creating a toolboard or toolbox with the exact shapes of the tools to avoid any misplacement. And it goes on and on. So, which option would you choose? Obviously, it all depends on the situation that each company faces. However, in general, if possible, option 3 would be the most preferred option over the other 2 options. It is not easy because people will not voluntarily initiate improvements or creative ways to continuously look for opportunities to reduce task time. However, the best organizations always find a way to encourage or initiate task time reduction efforts. Sometimes people limit their potential for innovation. However, some organizations produce results by breaking out of the trade-off relationship. For example, cost and quality are in a trade-off relationship, meaning that if you lower the cost, we may expect or think that we need to sacrifice quality or vice versa. True innovators are always looking for opportunities to break these traditional trade-off relationships, meaning that they find ways to maintain or even improve quality while reducing cost. It may not be easy, but if you find a way to make that happen, you will be able to enjoy a competitive advantage. Look at the picture on the slide. Let's say that the horizontal axis represents cost, high to low, and the vertical axis represents quality, high to low. Some companies may target the low-cost and low-quality market, like Hyundai in its early stage, while some others target the high-cost and high-quality market, like many luxury car makers such as BMW, Mercedes, and so on. Because you need to be brave to target either the luxury market or the low-end market, most companies tend to compete in the middle market, saying that their products offer an affordable price and acceptable quality, resulting in intense competition. If you can find a way to move in a so-called vector direction, such as Toyota, for example, they can create a new competitive frontier line, different from the conventional frontier line. Once you create a new and superior frontier line, you will also have more flexibility to move up and down, but still remain competitive compared to the players on the conventional frontier line. Many people claim that there are limited resources or constraints, but some leading organizations or individuals still create innovative solutions by breaking down the trade-off relationship. Future operations in the era of digital transformation will change from sequential to network-based. In the past, workstations were collocated in order to take care of their own tasks. If one of the workstations was out of order, the entire line would stop until the workstation's problem was resolved. However, in future operations, if you have an out-of-order workstation, the system will look for an alternative option that can perform the task and redirect the flow of materials. In addition, modern operations can even be designed not as a series of sequential activities or firms, but as an ecosystem that is connected through a platform. Many modern business models are created based on platforms, as you know, including Uber, Airbnb, and so on. More specifically, there is a concept of a smart factory where machines are connected by 6G communication technology, cloud and edge computing, smart sensors, and so on. People just monitor and control the entire system and take care of abnormal or unexpected situations. Through VR and AR technology, people can monitor the inside of machines and forecast potential outputs too. In the past, we took some samples from the entire output due to the cost and time required to test all outputs produced by operations. But now, testing the entire population might be possible, resulting in no need for statistical quality control. More recently, humanoids, which are human-like automated robots, have been introduced to take care of dangerous and labor-intensive work. While a smart factory requires changing the entire flow of materials and information based on the capability of machines to take care of each task, humanoids have great benefits because they can simply replace current manpower. These machines do not complain, can work for 24 hours, and perform each task more precisely. Early versions of these humanoids will automate tasks that humans used to perform. However, as AI technology develops further, machines will become full-fledged intelligent agents that may be able to perceive, make decisions, and interact with others. Obviously, this may require combining large language models, LLMs, and vision language models, VLMs, with the development of physical robots. Most of the AI applications that we use today are designed to solve specific problems. For example, translation, creating images, summarizing existing information, and so on. As we move forward, this will be applied in various industries by combining industry-specific knowledge and technology with AI, which will make industrial AI available. In order to develop effective industrial AI, we need to understand how industries work, the existing technologies with industry-specific knowledge, and the available data. This is why operations matter in the era of artificial intelligence. We discussed the basic variables that we can consider to make an improvement. In our process analysis, we had 3 variables: available time, available resources, and task time. Depending on the situation, you may want to choose a different variable to make an improvement. However, it is important to consider selecting the more preferred option that can break down the trade-off relationship and still create innovation. We also need to understand that future operations will be quite different from how we work today. One important thing is that we need to understand current operations and technology in order to effectively develop AI applications that can be utilized for future operations.